Okay, today's lesson we're going to look at our trig graphs and apply this now to solving trig equations. And if you remember back in the last chapter, we were solving trig equations algebraically. So let's actually do this title question algebraically to see if we remember how to do it. So remember what we'd want to do is bring the cosine over. So we'd have 10 cos theta. Bring the 5 over, so that would give us negative 3. We would then go cos theta equals negative 3/10. And then remember we would, on our calculator, go shift cos of negative 3/10, and we get an answer of 107 degrees approximately. So remember then, once we have our one solution, we would then take our cast rule, because we have to find both solutions from 0 to 2 pi. So 107 degrees would be somewhere over there. So that would give us 73 degrees as our reference angle. So where else is cosine going to be negative? Down in this quadrant. So we should have 107 degrees, or in radians, if we convert that to radians, that would be 1.87 radians. And then we would also do 180 plus 73 degrees, which is 253. And we can convert that to radians as well. Times it by pi, divided by 180, and we get 4.41 radians. So remember doing these, we would solve the algebra, find your solution, use the cast rule to find the other solutions, and that's it. So what we're going to look at today now is doing the exact same thing again, but actually solving these by graphing. So what we want to do with a graph, let's go back here, I skipped a page I think. Oh, no, I just showed this here. So this was our algebra, which I already did on the title page. So now what we want to do is solve these things by graphing. We got two different methods, just like we did before with graphing, is we can rearrange the equation, make it equal to 0. Then we just have to find the x-intercepts. So you'd graph your graph, and let's suppose it's just a regular sine graph. It would look something like that. And then all we'd have to do is find our x-intercepts, all x-intercepts in whatever range. So if the question said from 0 to 2 pi, then we'd have three solutions. We'd have 0, pi, and 2 pi. If the question said what is it in general solution, then we'd say we're going every pi apart, so we just say pi n. Okay, so whichever way we'd have the right solution. The other option is to draw the graph, both graphs, so if you have a left and a right. So let's suppose we had some sort of sine graph, and let's suppose we had it equal to 2, or equal to half. We could just draw a second line, and then what we'd do is we'd find our intersection points for where that graph crosses that line. So in this case, we'd end up getting those points, and same thing, we do it within whatever range we're looking for. So let's try a few examples. So the first one is sine x equals a half. So let's do it first let's make it equal to 0. So if we have sine x minus a half equal to 0. So in our calculator, we'd graph that. So when we graph that equation, we see that it ends up being shifted a half to the left. So our graph does something like so. And then we'd want to find all of our zeros between 0 and 720. So we'd find those intersection points. We'd end up getting pi by 6 because we're moving it over a half, a radian. Or sorry, we're going down a half, not to the right, right? This is on the end, so it'd be down a half. So we'd end up getting, instead of going from 1 to negative 1, we're now going from a half to negative 3 halves.
Could the custodian for wet cleanup outside the staff door, please?
So we end up getting pi by 6, and from our graph, just use your calculator, figure out these intersection points. So we get 13 pi by 6, and go to the next one, we got 17 pi by 6. So that's up to 3 pi, which is 1.5 rotations, so we just got to keep going a couple more times. 25 pi by 6 would be the next one. And our last one is 29 pi by 6. Okay, and if we keep going, we'd then be past our 720. So these were in radians from your calculator, but we could have also solved it in degrees. So when you do this on your calculator, just set your x in degrees, and we would have got 30 degrees, 150, 13 pi by 6 is 390, and we just keep on going. So you'd have all of your degree answers up to 720. Okay, so that's pretty straightforward. Let's just clear this and look at the other one. So yeah, in this case we'd have 30, 150, 390, 17 pi by 6 is, I can't quite do it in my head here, that would be 360 plus 180 is 540, less 30, I think it's 510, and so on. We get the two more after that. Let's clear this off, and let's try solving this now by using the second method and see which way is easier. So in this case, we'd have sine x equals a half. So we just graph y equals sine x. So that's our regular sine graph. And then what we do is we look for our second equation, and we graph it as y equals 0.5. And if we do that, then all we have to do is see where they cross. So we graph our two equations, and it'll look something like that, and we basically do the same thing. So now we want to find where they intersect. So in this case we'd get our 30 degrees as well. Find this one, it'd be a 150, and away we go. So we continue on, we get 330, all of our same, or sorry, 390, all of our same answers that we had before. 410, or 510 I think it was, and whatever the next two would be. Okay, so you get the idea that when you're drawing these things, or solving these things by graphing, it's usually pretty easy. You just have to type in your equation, find your x-intercepts, or in this case, type in both equations and see where they cross. So let's try another one. Here we got sine 2x equals a half. So let's draw this one using two equations. So sine 2x, remember, is just going to be a graph that is got half a stretch, half horizontal. So instead of crossing at pi and 2 pi this time, so our graph is going to go up and back down, and that's going to occur at pi instead of 2 pi if we do a half the stretch. So that would be at, let's keep this in radians, this would be our degrees, 180 to 90, and 180 would be our intersection points. So then it would repeat again at 270 and 360, and then it would repeat again for the next revolution up to 720. So we're going to get a whole bunch of these answers. And once again, if we just graph our second equation of y equals a half, all we have to do now is find our intersection points. So in this case we would get 15 degrees, and the next one's at just under 90, less than 15 would be at 85 degrees. So we have 15, 85, go to the next two. So the next one's at 180 plus 15, which would be 195, and then the next one is at 17 pi over 12, my Desmos is giving me. So you just have to be careful converting them from radians to degrees, and we basically just keep going with that pattern all the way up to 720. Okay, so you get the idea. It doesn't really matter what the equation is, it's pretty easy to do on your calculator. Okay, let's try one more. This one's pretty tough. So we got 3 equals 16 cos. We got a whole bunch of different things going on. And like once again, we can do a little bit of simplifying if we want, which in this case might not be a bad idea. So let's bring the 5 over. So we get 8 equals 16 cos 5x plus 1. And let's even divide by the 16. So 8 divided by 16 would give us a half. So that makes it a little bit easier to work with. So we'd have cos of 5 brackets x plus 1. So when we graph that one, now we can see that we basically get a 1/5 stretch, so we're moving this thing 5 times closer. So our cosine graph, and we're moving it 1 up, so it gets shifted upwards a little bit. And, or sorry, not 1 up, we're 1 to the right. So our graph gets shifted over a little bit, so it's starting somewhere up here. So our cos graph does something like that. And our second line, y equals 0.5, something like that. And then once again, we basically want to find all of our intersection points. And this one we're going to do in radians. And we can do these as decimals, fractions, it really makes no difference. Let's just do this one in decimals. So the first one I get is 0.047. Go to the next one, it's 0.466. And we keep going. The next one is at 1.304. Our next one again is 1.723. And we want to go up to pi this time, so we want to get up to 3.14. 2.56 is the next one. And 2.979. And I think that's it. Yeah, the next one is past pi. So you can see we've got a whole bunch of solutions from 0 to pi, which was somewhere in about there. And that's it.